What's up, drops and droplets? We're back again this week for a more informational video. In today's video, we'll be telling you more about our project. We skimmed through the project before in the previous video, I forget which one, but we'll be able to show you more files and drawings, so stick around for that. We'll also show off some of our SolidWorks practice that we've been working on. Along with that, the progress we made so far in this project. Then at the end of the video, we'll be talking about our next steps and assignments in this project. We'll have each of our team members tackle one aspect of the progress one at a time. Be sure to stick around till the end to learn what we've been doing so far. And be sure to drop a comment in the comments down below to enter a giveaway for a high five. Without further ado, let's catch up.
Now, these are some drawings of a pump. Our primary goal, as inside white water, is to model the pump in SolidWorks. Right now, these models are created in AutoCAD, a computer-aided design program. However, the problem with this, like the previous image, this is one of the other images that we have to model ourselves. And if we scroll up, we get to see some of the specs for the pump, such as the fact that it's a 12 MOH5 right here, as well as the site that we're building it on, which is Wapahu Wells 4. Number 2 indicates which pump we are modeling, and there are 4 pumps in the site in total. Now looking back here, we get to see some of the more complicated models of said pumps. These models show the valving of all of the pumps, and we actually did some of this ourselves. These will be discussed later in the video. We also had to read some files and specs that we were working with, and those would also be discussed later in the video.
This is the first view you get. It gives you most of the information you'll need to accurately model it. But if you look up here, we can see a section detail of this upper half to give us a little bit more information so we can more accurately model it to make it more true to life. This is what a real life version of it would look like, this round upper part. And this is the 3D model me and one of my teammates in our group made. I think it's looking pretty good if you ask me, actually.
So everyone in this group is CSIT WA certified, which is Certified SolidWorks Associate. Basically, we did an exam last year and we got certified to do SolidWorks on an associate level, I guess. The part I was tasked to do was discharge piping pressure line. If I'm being honest, there wasn't really much for me to try to create. The notable things I made in SolidWorks was this iron pipe. I was assuming that this was also another pipe, but just copper. I could be wrong because that's like some schematics. That could be part of the valving and electrical components. But I just made a pipe just in case, and I also tried to make this ball cock right here. So this was the ductile iron pipe. I was doing some specs. It's like the diameter of the hole determines the length also. So for this one, since it has an inside diameter of 8 inches, it would have to be, I believe this is 19 feet. So it had to be 19 feet long. Then this is the 3/4 inch copper pipe. I'm assuming it is a pipe. I just made this just in case. Then, unlike the previous ones, I had some BWS standards and specs for it. So for this one, I think with the type of copper, then like how long. This one, it was also the diameter and length. But for the ball cock valve, so using that, I searched up how a ball cock looks. This is sort of what I came up with, and I just modeled from there, trying to make it just to see how it fit. Yeah, this is the things I modeled in SolidWorks so far.
So hello, my name is Isaac Asserit. I had to 3D model the pump control valve. for those who don't know what a pump control valve, it's basically the valve that opens and closes an adjustable speed. So it provides a smooth and I guess predictable transition of the discharge flow into the pump itself. So I had to 3D model it, and it was pretty difficult to 3D model it just by itself. So I had to split up the pump into separate parts, as you could see with my different drawings. I had to split it up from the entrance tube to the parallel cylinders that connect the rods, and I had to separate the top part of the pump control valve, which required lots of chamferings and cuts and extrudes.
So in addition to 3D modeling the pump, we were also tasked to pick a pump using different softwares provided by different companies. So pretty much we looked online and tried multiple companies until we landed on this one. This graph pretty much tells us how well the pump is performing under its different circumstances like flow rate and head height. Since we were given specific specs necessary for the pump, the process was simple and we just had to pick the most efficient pump that met our needs. It also includes additional information about the pump, such as its maximum power shown on the left, but we're only really looking for where we need the pump to perform, which is right at 1050 gallons per minute at around 236 feet.
A tool that has been very crucial for us to stay on track for this project is called a Gantt chart. This is to visually represent how many days we have to work on a project and when it's due. On the left side, you can see each row is representative of a assignment we have or a task, and then you can also see the status of the project, who it's assigned to, our progress on it, the start and end dates. On this right side, you can see, the days of a week in a calendar, and this is to represent, what is due and what it is and how it compares to every other assignment that we also are working on simultaneously. As you can see, this blue bar is coming to an end quite shortly, so that means in 2 days this is going to be due, and this is the editing of a video that's going to be going up in a short period of time. This Gantt chart is specifically related to anything to do with YouTube. We also have a second Gantt chart for anything to do with 3D modeling and communicating with the Board of Water Supply.
Moving on, here's a sample specification sheet that we were given. It includes all the necessary info about the pump and how it needs to be worked on depending on the project. It includes a lot of numbers like elevation and where parts are located, and it also includes a lot of words that mostly describe what's happening to the pump and industry standards.
And this is our spec sheet. The point of us creating a spec sheet was to list all the necessary requirements in an organized and easy format to understand for us, BWS, and our advisors to see. To create this, we actually had to use a couple of files that you saw before, such as a sample spec sheet, some drawings. There's a file called Waipahu Wells 00880, which we use primarily to find most of these. Then for things such as, where is it? I think right here, the pump requirements, we actually had to create a pump curve to figure out some of these requirements. So going down, for the most part, it's all numbers and data. So like the elevation of the sounding tube has to be negative 15 feet. And our pump curve had a overall efficiency of about 82.9%. So that's what I think, let's see. So going more down, the first 5 pages relate primarily to the specs of the pump and such. So it has all sorts of like the head, the power, engine, etc., and the overall length, while the rest of the 31 pages relates to more in-depth information about each part of the pump. So that could be like the discharge column pump, where they give like more specified things to talk about, such as this should be steel pipe. And going more down, let's see, the maximum temperature is 77 degrees Fahrenheit. Yeah, so this is our spec sheet.
Before jumping into the 3D modeling process on SolidWorks, we're going to have to go through more files provided by BWS and determine if the part or drawing they sent will be useful to our pump. Once we determine if that part/drawing will be useful, that will be used to 3D model. So everything will not be on the drawing. We'll do more research to find more specs about the part and further our progress with the drawing and creation of the part. Once we are done completely 3D modeling our valving, we're going to move on to the actual submersible pump itself and the components that make up the submersible pump. Simultaneously, we're going to start researching the specs regarding the pump. This allows us to update our spec sheet, which we're going to send to the BWS team so they have an updated version. Once completed with all the parts and components of the submersible pump and 3D modeling it, we're going to put it into our engineering notebook so we can record our progress. And that'll wrap up today's video. Thank you to those who stuck around. I hope you guys found the information very informative. Make sure to hit the subscribe button and the notification bell for any upcoming videos. Make sure to leave a comment if you guys have any questions regarding our team or the BWS team. Also, make sure to leave a like just so we know that you enjoyed the content.